Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the Seagray 2023 Grid of the Future Symposium. And these interviews are with the leaders at Seagray and the leaders of the industry. Hope you enjoy. My next guest is James Berger. James is what's your title?
I'm an electrical engineer.
Well, see, if one of the things to set up for this, you're at Power Engineers. One of the things to set up is I'm supposed to be interviewing the James Berger from AEP. And so I did all of my research on that. I'm going to have to start over with you. Tell me a little bit, first of all, how did you get involved in the power industry in the first place? I mean, most people go to school and they don't think about, even if they think about a double E degree. Are you a double E?
Yes.
They don't think about the power industry. It was a dirty, old, unsexy industry. They got into electronics and they got into, nanotechnology. Why the power industry?
I thought it was interesting. When I was going back to school, it was not right when, but we were getting really big on renewables.
Okay.
Starting, large.
And you're in Colorado, so
yeah. Colorado. So it just seemed to make sense. I actually started school in California, and they're real big on renewables.
Yeah.
It seemed like it was going to be an interesting place to be long term.
Okay.
And more of a fit for me than aerospace or nanotech. Didn't really interest me. Didn't really speak to me.
Talk a little bit about Power Engineers, your role there.
So I work with our distribution studies team. I primarily work on grid modernization projects. So I do a lot of system impact studies for renewables. I do a lot of advanced technology solutions that are going to help support the grid, whether it's voltage or reliability through automated system reconfiguration, things of that nature.
So if you looked at it, we just had a gentleman on and he was talking about the old school where we generate power, in these big load areas. We send it down the pipeline, make the pipeline big enough transmission, and then we distribute it. And we created a very reliable grid as a result of that after the debacle in 2003 when we lost the whole northeast power part of the country. But that's not the grid anymore. I mean, with DER, now you got generation that's localized, wind to the solar. You got ratepayers have become consumers, have become prosumers because they got solar on top, a car and a battery, and now they want to give you power, give the utility power. Utilities are trying to modernize the grid, and they're trying to create a flexible grid. When you look at that as an engineer, as a consultant engineer, how do you allow them to harden it, which we also want to do from all kinds of threats, but make it flexible? It seems almost like it's counterintuitive. You want a hardened grid that's flexible. Talk about that.
There's a lot of struggles there. You're exactly right.
That's why you have a job.
It's not going anywhere,
That's right.
We really did build the grid to send power one way, and sending it back the other way, it changes how the equipment has to function. It changes how the system has to be protected. It changes how you look at the whole picture. So, how do we keep it reliable with all the distributed energy? That's something we're currently working to figure out. There's ways with automated reconfiguration schemes. You have to take all that into account. The inverters on the solar, they have to look at various different things. When are they going to turn off and turn back on?
Yeah.
Everybody's starting to figure out, how do we establish a market for this, like a large scale market for consumers to now sell energy back, and looking at all the different points on your system. You need to, what's the word I'm looking for, collect all that data somewhere to analyze it, so you can have different sectors of the system that perform as small markets rather than each consumer. There's so much going on. I could spend the whole time talking to you about just.
It's a good time to be in the industry. You mentioned something about the inverters from solar. I think it was Southern Cal Edison reported that their distribution transformers were failing at twice the rate they were because of transients and harmonics and problems from an inverter-based system. So now you got a hard asset, the transformer, which I think is the heart of the system, now suffering. And then I've heard from other people, it's not just transformers. The equipment itself is aging more rapidly as a result of an inverter-based system being introduced. Talk to me a little bit about that, your experience.
Yeah, I mean, I think a big thing there is just we don't have regulation standards in place for it. It's one of the ways that the industry is ahead of where the regulation is. So
Okay.
as you do these studies and you look at impacts of generation, distributed generation, the way that you study it, the way that it's looked at varies from client to client that I work with. There's some fairly standard industry practices on what you want to look at, but there's a lot of things that some folks are concerned with, other folks are less concerned with, and that's going to create problems as we move forward at this rapid pace.
You think?
Yeah. Well, I think the other piece is, like we were just talking about, the equipment wasn't designed with that intent. A lot of those distribution transformers, they've been there for a long time.
Yeah.
And they've been reliably performing their job, but now their job's different. It's not what it used to be.
That's a good way to put it. The job is different.
Yeah. So you're doing a different job with the same equipment, and it's going to be tricky. You're going to have those challenges.
So you mentioned twice now, you said the word data. That's another thing that's changing is we're going to where it used to be you do maintenance, right? You go out and do it on a time base. Now it's condition based. In order to do good condition based maintenance, you have to collect good data. You have to have monitors. You suddenly change the whole dynamic. Obviously, if you're power engineering, you're using data solutions to help people solve problems, correct?
Yes.
Talk a little bit about data and what you've seen in terms of both the problems with it and some of the solutions.
I mean, one of the problems is just there's so much data now. With smart meters out on the system, you have millions of data points that you can look at. And one of the issues is being able to filter through that data and make it useful for what you need. And what you need depends on who you're talking to. Is it an asset manager? Is it a system planner? Is it a studies engineer like myself? All of those groups have different concerns that they're looking at that same data for. So, I mean, I was just in a paper session and we were talking a lot about asset management and trying to use our current data to predict what the future is going to look like as best we can, because we don't have a crystal ball,
Yeah.
How does that impact the decisions moving forward? How are they different than they were in the past,
ISO 55000 is an ISO regulation about data, about asset management. And the main concept, and I'm simplifying a very complex ISO, but the main part of it is that you have line of sight from even the CEO level down to the engineering level, to the operator on the floor, a line of sight of the same asset. So the CEO can see what he needs to see, the CFO can see what she needs to see, the COO needs to see, but so does the operator, and so does the manager of I mean, it's a very complex when you start looking at true ISO 55000 principles. I think there's only one, if I'm not mistaken, I think PG&E implemented ISO 55000. They spent millions of dollars implementing. What they did was when they found it on the gas side, they found hundreds of assets, major assets that they had written off on the books that were still functioning today. Now think about that. Are they being maintained if they're written off on the books? And they're written off on the books. Well, we should have bought a new one, but we didn't. So how is it still operating? It was on the gas side, natural gas pumping stations, right? Not picking on PG&E, but that's everywhere. I mean, you're talking about when you look at utilities, they've got equipment everywhere. They got rolling equipment coming out there. But when you talk about doing a study, talk to me about start to finish. What does it look like for when you do a study? Sell your service to me.
Well, let's say we're doing a system impact study.
Okay.
Step one is collect all that data we were talking about.
Okay. See, I knew data was in it.
Yeah. Well, you need to verify the models. You need to make sure it's reliable. You need to make sure that what I'm looking at is as realistic of a picture as I can get. Obviously, being a model, it's never going to be 100%. And from there, you look at what's the new asset that we're adding into the system and what kind of impacts are we expecting to have. So a lot of times you're looking at, is there going to be overloaded equipment when we put this new thing on the system? Are we going to be sending a lot of energy back up through the transformers into the transmission system?
Yeah.
Another thing we're just talking about. And from there, we need to consider the protection implications of that. How is a system that's used to looking at power flow downstream going to respond to the power flowing upstream? How will it know when there's a problem? How are you adequately going to be able to use what's on the system to protect your equipment, you know? And what do you need to upgrade? Sometimes you can't use this on the system and you need to be upgrading your circuit breakers or your lines or various other pieces of equipment. You need to worry about the voltage stability. But, solar, for example, with the cloud blowing over and that solar drops to zero and then it picks right back up, that causes issues with the voltage on the system and the frequency. And how do you look at that? What are the mitigations you can put in place to ensure that that issue is not going to cause your customers problems or your larger system problems?
We were just doing this at the RE Plus conference in Las Vegas 3 weeks ago. Renewable Energy Plus. I was at the first one that I went to 3 years ago doing these kind of interviews, and I think there was 12,500 people there. Last year, there were 15,000 people. 3 weeks ago, it was 40,000 people. Wow. And one of the reasons was there was a huge emphasis on storage. I mean, you had a lot of ESS companies there, that had, flow batteries. They had utility scale storage, which has been one of the solutions for wind and solar. If you can use this, actually use the storage as a buffer, if you will, and then you can, but at the same time, you got to crank that storage up when it's needed, right? So have you worked any with storage systems that you see that are making a difference?
Yeah, so currently I'm working on some battery storage impact study specifically. And
I knew that, and I asked the right question.
A lot of the interest in those, a battery system's not going to support your grid long term for even like an hour.
Right.
It's going to be used largely to ride through those disturbances like the solar dropout.
Right.
As soon as that drops out, that battery system needs to kick on and support the system. But even then, the type of generation that renewables are versus the type of generation we're used to changes the dynamics of the system. It used to be that you would have some inertia from your generators. So if your frequency starts to dip and your voltage starts to dip, it's pulling that mechanical energy out of your rotating generator to support it. Well, a solar panel doesn't have that energy. There's no dynamic energy in that. It's either going or it's not. And so that's another challenge that we are facing and having to figure out. There's some interesting solutions that I've read about in the UK, for example, where they're developing, it sounded like essentially an inertia machine. So they use energy from the system to start this rotating, and it helps ride through those system disturbances when the voltage drops out. So they're creating a machine just to solve that problem. So there's a lot of interesting stuff. And as far as energy storage, I think a lot of people focus on batteries, and that's not a wrong thing to focus on. But so I read an article, World Economic Forum article about lithium supplies in the world and how they're thinking there's not enough lithium to do this if we use lithium batteries like we are. Right. So we need to work on, and I know people are working on battery technology, but what other types of energy storage can we use? How can we use, for example, the offshore wind how can we store that energy in a way that we can use it if that wind is blowing at night and our load is during the day? And there's a lot of great ideas. When I was at the Seagray Paris conference last year, there was a gentleman from, I think, Scotland talking about
where I was born, by the way.
Oh,
because if I'd done this interview in Scottish, you'd have had a better interview. Go ahead.
Well, he was talking about the offshore wind they have there, and it blows a lot at night and not as much during the day. You need it. So one solution that's discussed, I think at least a couple places in Europe they're doing it now, is you use that offshore wind in a hydrolysis machine to separate out the hydrogen, and then use that hydrogen to power stuff during the day. It's just another form of energy storage. It's pumped hydro.
Exactly.
We have some in Colorado that's, the next state over. They pump it up the mountain when they have excess energy, and they run it down through a turbine when they need that energy. So I think energy storage, a lot of times, I appreciate how we're starting to look at it more broadly.
it is not going to be a lithium solution, as you say. It's not going to be just a flow battery system. It's a completely different approach. I consulted with a hydrogen monitoring company, H2Scan, for several years, and knew the founder of the company. So I did a lot of work in hydrogen, and I happen to think that hydrogen as a storage solution made from offshore wind electrolysis, I mean, it's got so much capability, but nothing is as safe, because when you think of hydrogen, you think of what? The Hindenburg, right? Everybody's got it. But last question I'm going to ask you. You mentioned Seagray a couple of times and being at a conference, the Paris conference. We're really pleased to be invited by Seagray to do these interviews at their U.S. National, whatever, the Seagray Symposium. Talk about the value of Seagray to both you and the company.
So to me personally, it's been a great experience to help get more involved in the industry, learn more about trends, meet people. When I first got involved, it was my first year, I think, of professional work experience. I became involved with the Next Generation Network. I got the opportunity to be on the executive committee. I'm now chairing that committee, and it's been a wonderful opportunity to travel around the country and around the world in some instances and be able to see what other people in other utilities, other consulting firms, other countries, how are they handling the same challenges that we're attempting to address here in the U.S.
Yeah.
And for power engineers as a company, it's a great way to stay involved and to showcase our understanding and our ideas of what we think are good solutions and how we're able to help our clients and support them through this transition. And it's a great place, to learn, to present, and to network, really.
Yeah. You're the chair of the NGN, the Next Generation Network.
Correct.
So we ran out of time for this one, but I want to do an interview with you. We'll do a Teams interview, so we're not do it here, because I really want to focus on the Seagray Next Generation Network, because I agree with everything that's happening there, and I'd like to make a commercial that we really talk to engineers about why it's important to be part of an organization like Seagray. So since you're the chair, I'm asking you now, will you be committed to do that Teams meeting? Tell me all about NGN, what's happening, how it's working, and make a recruitment podcast or broadcast for this. All right?
Absolutely.
Thank you so much. Appreciate it, Zane.